Hello everyone, welcome to another JC Math Crash course. So today we'll be looking at differentiation. So the thing with differentiation is that there are two parts to it. The first part is mainly theory, and then the second part is about applications. So theory can mean just how you differentiate things here and there, what are the certain formulas. And so I'll go through that first, the content and then the questions. Then for differentiation applications, I'll go through some more content on that, as well as some of the questions. Finally, I'll just go through a bit of a summary as well as a list of things that you have to memorize, which I'll leave in the description below as well. So this is just some reminders as well about differentiation in general. So whenever a question asks you to have your answer in the simplest form, when you have a fraction in a fraction, it does not count as simplified. So this means that your numerator cannot be a fraction, or your denominator, it cannot be a fraction either. Then if your x is in degrees, like let's say 120 degrees, we have to convert it to radian, and how we will do so is that we'll multiply by pi over 180. So when it asks the exact form, you can use your pi, trigonometry, and anything else that's available like logarithms. And then dy dx can also be interpreted as tangent x, because dy dx is meant to be the gradient. So it's basically the rise over run in an xy plane. Then in the case of real-life objects, there may be a lower limit or upper limit concerning the radius of our object and other dimensions which should be accounted for when sketching the variation or volume as r varies. So we know that for a real-life object, the length cannot of course be less than 0, and in other cases the volume cannot be less than 0 also. Or in the case of, let's say, a building, if we are already told that there's a certain dimension to it, it cannot exceed that value if we get it as our answer, so we have to reject it. So this is what I'll go through in terms of the theory. So first will be differentiation of standard functions, trigonometric functions, then implicit differentiation and higher order derivatives, followed by parametric differentiation. So the first part will just be about derivative of expressions that we previously learned in secondary school. So if you learn, the things you will learn in secondary school will be like, if you want to differentiate x to the power n, you bring down the power, then power reduced by 1. Then in the case of exponentials, if you differentiate it, it just remains the same. Then if you differentiate ln, it just becomes 1 over x. Then for trigonometry, if you differentiate sin x, you get cosine x. If you differentiate cosine x, you get negative sin x. Then if you differentiate tangent x, you get secant square x. If you're not sure how the tangent x becomes secant square x, you can simply use your quotient formula, where you let tangent x be equal to sin x and cosine x, and then you just evaluate from there. Then you should be able to get secant square x as well. So there are certain rules of differentiation that we learn as well. So the first is commutative rule. So if you differentiate afx plus bgx, where fx and gx are functions, you will just get af differentiated x, then b differentiated x. So then another thing will be product rule. So product rule just means that when you try and differentiate a function fx gx, you have the gx first with product differentiate of fx, then you have fx in another addition times g comma x. So then in the case of quotient rule, where your numerator is fx and your denominator is gx, how you solve it is that at the top you have gx first, differentiate fx, minus fx, differentiate gx. Then you divide it all with a denominator, which will be gx squared. Then in the case of differentiating a function with a function inside, you'll just differentiate the function outside first. Then afterwards, you multiply by whatever you can differentiate inside. Then in the case of dx over dy, is also equal to 1 over dy dx. However, take note that this doesn't apply when you have d square x over dy square, or like d square y over dx square. In that case, it's different, but for the case of dy over dx or dx over dy, when you differentiate once, it can be inverse. So these are the new differentiations that you have to, in a way, memorize or learn. So in this case, when you differentiate cotangent x, you will get minus cosec square x, which you have to memorize. But then for the differentiation of secant x, you will get secant x tangent x. Then for differentiating cosecant x, you get negative cosecant x cotangent x. Now the two formulas for secant x and cosecant x, both of them will be in MS26. But for cotangent x, you have to in a way memorize. Now, if you're not sure in the middle of the exam how to find the differentiation for cotangent x, you can simply break it down into the cosine and sine. So cotangent x is basically the inverse of tangent x. So in this case, cotangent x is equal to cosine x over sine x. So then you can use your quotient rule to differentiate, and then you can eventually get cosecant square x as well. Then if your angle is of course measured in degrees, do convert it back to radian as well. Because most of our answers, if not all the answers that we give for A levels, will be in the form of radian. Then yeah, likewise, if you have a function rather than x inside your cotangent, secant, or cosecant, you will differentiate the cotangent first, so you get cosecant square fx. Then you multiply by the differential of fx. Then another thing is that if you differentiate something like a to the power x or like 2 to the power x, what happens is that you get 2 power x times ln of x, no, times ln of a. Then if you want to differentiate a logarithm, which is a very rare question but it can come out, it's going to be 1 over x ln a, where the logarithm has a base a. This is derived from the change of base rule, but you don't need to remember that. You just need to know those two formulas specifically for a power x and log x. Then likewise for differentiating cotangent x, you just need to memorize it is minus cosecant square x as well. Then yeah, so there's also some other things in MS26, which is trying to differentiate the inverse of trigonometries. So in here you will see that for sine inverse x, cosine inverse x, and tangent inverse x, that's how you differentiate to get whatever is there. So 1 over square root of 1 minus x squared minus of 1 over 1 minus x squared and 1 over 1 plus x squared. Then if you have a function inside, you replace your x with the function as well. But remember to, of course, differentiate the inside. So in that case, you have, instead of a 1, you get a f prime x. So the f prime x is just differentiating fx. And take note that sine inverse x is not equal to the whole of sine x inverse to the power of 1. Wait, sorry. The sine inverse of x is not equal to taking the entire sine expression and making it power minus 1. Because sine x as a whole to the power minus 1 is just 1 over sine x. But sine inverse x is like when we have sine x equal 30 degrees, then you want x, we sine inverse the 30 degrees. So that's the difference. Then there's this thing called higher order derivatives. So first, in secondary school, you will learn dy dx or d square y over dx square. So now we will learn that there can be infinite amount of derivatives essentially. So you can have a third derivative of y where you differentiate d square y over dx square to get your d power 3y over dx cubed. Then likewise for the n derivative, it's just basically differentiating d power n minus 1y over dx power n minus 1. All of this with respect to x. Then another thing will be implicit differentiation. So instead of, like, imagine differentiating an expression containing x and y with respect to x. Then to solve this, we need to differentiate y. And when we are differentiating y, we cannot express this as an equation anymore. We have to differentiate y as it is. So in that case, we will have a temporary holder in the form dy dx, and then you do your differentiation of y. So alternatively, let's say we want to differentiate y cubed. When we do this, the output will be dy dx. Then you differentiate the y power 3 with respect to y. So in that case, you bring down power reduced by 1, you get 3y squared. So that's how you do implicit differentiation. So here are two more examples. So let's say you want to differentiate x squared minus xy plus y squared equal 4. So if you want to differentiate it, you will get 2x minus, then you do your product rule. So x, then dy dx. Then you will differentiate y, but since when you differentiate y with respect to y is just 1, it's just x dy dx. Then, on the other hand, you will just have y, then you differentiate your x is just 1. Then likewise, for the y square, you will just bring down power reduced by 1, you get 2y. Then you need to add your dy dx there as well. Then to differentiate 4 is just 0 because it's a constant. So afterwards, you group and factorize all the things together with dy dx. Then you bring everything else to the right hand side. Then you make dy dx the subject, so you just bring your minus x plus 2y to the denominator, and then that's your answer. Then likewise, if we want to differentiate x cosine y equal 3y squared, you will just use product rule for that as well. So for the first part, you will get x, then you differentiate your cosine y. So what happens is that you differentiate your cosine y, you get minus sine y. Multiply that by dy dx. Then afterwards, you have your cosine y times the differentiation of x, which is just 1. Then on the other side, you differentiate 3y squared. You have the dy dx over there as well. Then you bring down the power 2, power reduced by 1, you get 6y. So, and then you group everything with dy dx to one side, everything else to the other side. Then you make dy dx the subject. You will get cosine y over 6y plus x sine y. So that's how you do implicit differentiation. Then the last part is differentiation of parametric equations. So if we let a curve be defined by the equations x equal ft and y equal gt, we may not always be able to find dy dx directly. All we can do is we find dx over dt and dy over dt. So the thing is that dy dx is equal to dy over dt times dt over dx. This is what we learned in secondary school from our chain rule. So if we just compensate the dy dx and split it up, we can add a dt inside. Then likewise, after that first line, we can let dy dx equal dy over dt times dt over dx, which is equal to dy over dt divided by dx over dt. Right. Okay. Yeah, so for example, if we want to find dy dx where x equal 1 over 1 plus t and y equal t3 over 1 plus t, we will look at x and then we differentiate with respect to t. So in this case, we bring down the power, which in this case is 1 times 1 plus t, power negative 1. We can bring down the minus 1. Then our denominator, we just increase the power. So now it's squared. Then likewise, for y equal t squared over 1 plus t, we will differentiate to get 2t over 1 plus t squared. How we get this will be using quotient rule. So finally, dy dx is just equal to dy over dt divided by dx over dt, which in this case will be minus 2t minus t squared. So now we'll go on to a few more questions. The first 3 will just be standard functions. Then afterwards, I'll give 3 more examples, which were either A-level questions or prelim questions. So for the 3 differentiation of standard functions, we look at the one on the left-hand side first. So if we want to differentiate 2 power x, we can make reference to the formula that we memorized. That the differentiation of 2 power x is just 2 power x itself times ln 2. So how we did this is the method and the breakdown. Basically, we are going to let y equal to power x. Then we apply a ln to both sides so that we can bring the power x down. Then we will differentiate everything with respect to x. When this happens, we differentiate ln y, 1 over y times dy dx equal ln 2, because the x will just cancel out. So we let dy dx be the subject. Then finally, we will have dy dx equal to power x times ln 2. Yeah. Then in the case of d over dx of ln x over 4, actually what happens is that we can split it up so that ln x over 4 is just equal to ln x minus ln 4. This is one of the properties of logarithms and lns. So when we do this, we end up getting 1 over x, which is the same differentiation as 1 over x. So actually, if your x has a multiplication or division and like 4 or any other constant, the differentiation is always just 1 over x. Then the last part, if you want to differentiate cotangent inverse x, we let y equal cotangent inverse x. So then we cotangent both sides essentially. So cotangent y equal cotangent inverse, so that neutralizes just x. Then we will differentiate with respect to x. So we will get negative cosine square y times dy dx equal 1. We make dy dx the subject. It will be minus 1 over cosecant square y equal minus 1 over 1 plus cotangent square y. So you put that back in. And how we did that was using one of the trigonometry identities that you can find in your MS26. And then we get 1 over 1 plus x squared times negative 1. Then the next part, differentiate y equal x to the power of xy to get dy dx in terms of x and y, and then find the equation of the vertical asymptote. So likewise, if you ever see any funny powers, what we try to do is that we try to apply a ln such that we can get rid of the powers. So in this case, we bring down the x and the y on the right hand side. So and we bring the y to left hand side and the x to the right hand side. So in this case, it will be 1 over y times ln y equals x ln x. Then afterwards, we will differentiate everything and then we make dy dx the subject. So in this case, we will start with differentiating 1 over y ln y. So you will have minus 1 over y squared dy dx times the ln y, because we differentiate the 1 over y first, plus 1 over y times the differentiation of ln y, which in this case is another 1 over y times dy dx equal 1 plus ln x. In that case, it's also using product rule. Then, of course, we will try and make dy dx the subject, and that's how we get y squared times 1 plus ln x over 1 minus ln y. Then, for finding the equation of horizontal and vertical asymptotes, basically what happens is that if you want to have a horizontal asymptote, it basically means that the gradient is a flat line, and that is essentially a horizontal asymptote. So if you want to find out whether something is parallel to the x-axis, we will find that the numerator of dy dx is equal to 0. But in the case of denominator, that just means is essentially an infinite gradient, or in other words, vertical asymptote, and parallel to the y-axis. So in that case, when we want to find the vertical asymptote, we let the denominator of dy dx equal to 0, which in this case is 1 minus 1y equals 0. So y in that case equals e. We also know that y equals x power xy. So let's replace y with e, then we can find the value of e. No, then find the value of x. So afterwards you get that, you can use your graphing calculator to find the value of x, which in this case will just be 1.32. Then the next question is that a certain CAM software is designed to move a nozzle along the patch C described by the parametric equations x equals sine power 3 theta and y equals cosine cube theta minus 2. So then we want to find d square y over dx squared in terms of theta. So again, we will just take dx, take our x, take our y, then we differentiate each of them with respect to theta. So we find dx over d theta, which is equal to 3 sine squared theta cosine theta. Then dy over d theta is just minus 3 cosine squared theta sine theta. We bring down the cube power, so the 3 down, minus the power by 1. Then we differentiate the instead, which in this case is a cosine theta and a minus sine theta for x and y respectively. Then to get dy dx, we just take our dy over d theta divide by dx over d theta. So we put it there, and then it will simplify to minus cotangent theta. And when you want to find d square y over dx square, we're just differentiating our dy dx. So, and because we don't necessarily have our dy dx in terms of our x and y, what we can do is that we will differentiate with respect to theta, but then we will multiply back by d theta over dx, so as to compensate for it. This is part of chain rule again. So, we will differentiate our minus cotangent theta, which will be equal to minus cosecant squared theta. So the two minuses neutralize to make a positive cosecant squared theta. Then we have our d theta over dx, which is just 1 over dx over d theta. So we take our dx over d theta, put it in the denominator, and then we get our final answer, which is 1 over 3 cosecant power 4 theta secant theta. Lastly will be the A-level 2020 question. So a curve has the equation x squared over 1 plus x squared plus y squared over 2 plus y squared equal x power 3 y power 5 with respect to x. This is essentially something similar to the equation of conics, like an ellipse, a hyperbola, parabola. So afterwards, they want you to find the equation of the tangent at the point 1, 1, giving an answer in the form a x plus vy equals c. So whatever the question says, we just try and follow along with it. So we try and differentiate. So our left hand side will be differentiating x squared over 1 plus x squared plus y squared over 1 plus y squared equal differentiating of x cubed y power 5. So for the first part, we will just differentiate using our quotient rule, but for the y, we also multiply by a dy dx. Then likewise, for the right hand side, we will use product rule, where whenever we want to differentiate y, we will of course differentiate y itself. So y power 5 just become 5 times y power 4 multiplied by dy dx. Then for the other part of the product rule, it is y power 5 times the differentiation of x cubed, which is just 3x squared. Put them together. So afterwards, we get that entire long expression on the third line. So we don't necessarily need to make dy dx the subject, because they already tell us that we have the x value and y value, which in this case is going to be 1 and 1. So when we do that, we substitute all the values in. We can make dy dx the subject, which in this case will just be minus 5 over 9. And finally, we will just find the equation of a tangent, which will be y minus 1 equal minus 3 over 9x minus 1. Bring your things and arrange them here and there, you eventually get a value of a and a value of b, which in this case, your value of a should be 5 over 9, your value of y should be 1y, so b is 1, then your constant will be 1 plus 5 over 9, so it should be 14 over 9. So that's mostly it for theory. The theory isn't exactly that difficult. It's just very tedious in terms of trying to memorize what you need to memorize. The next part will be on applications, which will be a bit more difficult, but also quite standard as well. So this is the different parts of your applications. So you can talk about monoticity and concavity, stationary points, the graphs of f prime x, tangent and normals, as well as maximization and minimization. So the first part is just monoticity and concavity. This won't exactly be tested that much, and if it does, it will be 1 or 2 marks. But basically, in terms of the definition, a curve will have a monoticity if it is strictly increasing or strictly decreasing. And a curve's concavity is described as either concave upward or concave downward. What concave upward means is that the curve is just extending upwards. Then, in the case of concave downward, is that if you go from negative x to positive x, it will just have a downward set face. So concave upward is smiley face, concave downward is sad face. Then, the thing with monoticity, it can also be a way to prove if an inverse function exists, as it can imply a function being 1, 1. So, an example of something that actually doesn't have monoticity is actually the graph of, like, let's say a graph goes like this, then has a vertical asymptote here, then it goes like this. It is not strictly increasing, because as we go up here, then it go down here, because of the asymptote in the way. So in that case, it will not have monoticity. But for a function like a straight line, that can have monoticity, or like a graph of y equals ex, it's just an exponential going upwards constantly. So those will have monoticity. Then the next part will be stationary points. So finding dy dx should always be addressed as a number. The only non-number terms should be fixed constants such as a. Then when asked to find dy dx, we then afterwards sub the values that they give of x and y into the formula. Then another thing will be about stationary points of inflection. The thing is that if we have a maximum point, the dy dx will be positive, then at the climax is 0. Then when it decreases, it will be negative. Then for the case of minimum, it will be initially negative, it becomes 0, then positive. But in the case of stationary points of inflection, the dy dx sign does not change, which means it's always positive or always negative. Then when the fraction of a dy dx is equal to 0, we can conclude that the numerator is 0, but not the denominator. So, and if the denominator is 0, then the gradient is undefined. So then there will be some other questions which will ask you to sketch the graph of f prime x. I'm not exactly going to go into too much detail because there is another chapter called graphs and transformations, which I'll make eventually. But in general, a point of inflection on the graph y equal fx will usually correspond to the maximum or minimum point on the graph. However, the coordinates of this point of inflection cannot be determined by an observation. And likewise, if you have a vertical asymptote in your graph of y equal fx, you retain it before and after differentiating. And in the case of a horizontal asymptote, it will just translate to the x-axis. Then, in the case of an oblique asymptote, you will just turn it into a vertical line of y equal m, where m is the gradient of the original graph. Because as a curve converges towards the horizontal asymptote, the gradient is just going to be very little as it's traveling a really short rise over a long run. So that's why it's essentially the x-axis, which is your asymptote. Then your oblique asymptote, the gradient of the curve is always going to be approaching a constant value because it's going to go eventually tangent to whatever asymptote you have, which is a vertical, a rotated line basically. So that gradient will just be your new dy dx. So with dy dx, you'll get y equal m. So yeah, that's what happens when you get those kind of asymptotes. Then the assumption that it's not necessarily an assumption that you have to write out during your exam, but you just have to know at the back of your mind that all lines in the graph of y equal f prime x are going to be a curve unless it is a quadratic equation. Because if it's a quadratic equation, then you will just have, after you differentiate, just a straight line. Then next is about tangents and normals. So this is a question. The tangent to the curve at the point P xy meets the y-axis at 0h. So express h in terms of x and find the greatest possible value of h. So we will use the formula of gradient to get y minus h over x minus 0 and make the equation of straight line with the expression of the gradient. So what can be said about tangents as x approaches 0? The thing is that as x approaches 0, the tangent converges and approaches the line x equals 0, which is the y-axis. Then it told that the normal of the curve is parallel to the x-axis. This means that the tangent is parallel to the y-axis and can skip finding the individual expression for the normal. So for tangent and normals, if your dy dx is 0 over 1, this means the tangent is horizontal, and in that case, it's parallel to the x-axis. Then, in the case of dy dx, if it's equal to 1 over 0, so the denominator is 0, that means that the tangent is essentially vertical and will be parallel to the y-axis. So take note and try to remember of this as well. As usually they will be tested in questions saying, oh, find what happens when the tangent is vertical or when the tangent is horizontal. So bear this in mind. Then the last part will be about maximization and minimization. So to check if something is a maximum or minimum point, we can actually just place the equation of dy dx into our GC. So we can have our first graph in the graphing calculator will be y, then the second equation can just be our dy dx. Alternatively, you can just differentiate your first equation y in the GC itself. So you don't necessarily have to differentiate it manually. The GC can do that also for you. And an area of a polygon can also be found using a shoelace method that we learned back in Set 4, although that is not necessary and most questions usually don't require you to do it, but if you somehow remember it at the back of your head, you can always use this as a last switch method as well. And the thing also is that implicit differentiation works really well with finding the stationary point, since whatever is left on the left hand side will usually be equal to 0. Then in the case of maximization of an angle in a triangle, we can actually use cosine rule to define the unknown angle, assuming that the size in one angle is already given. So actually, there are a lot of ways you can use to express different angles, areas, or whatever as part of the question. So besides using cosine rule, you can also use your sine rule and your Pythagoras theorem as well to find different expressions for different sides and angles. So now we'll go on to the questions. And so yeah, this is what we'll be looking at. The rate of change, which is inversely proportional to radius. VJC question about a pencil. The rate of change of angles. The rate of change of area of triangle. And then some parametric differentiation. So the first question is JC 2019 prelim Q10. A machine is designed where sand is falling from the output chute. of the machine to form a pile in the shape of a right circular cone, such that the height of the cone is always equal to 4/3 of the radius of the cone. So given that volume is equal to 4/9 pi r cubed and the area is equal to 5/3 pi r squared, show that the rate of change A with respect to V is inversely proportional to the radius of the conical. So you first have to know that what V represents the volume and then A is the surface area. So, and they'll give you the formula for surface area in the question as well usually. So in this case, you don't need to worry about memorizing it, but it's just good to know. The surface area formula of a cone is really pi RL, where your R is your radius and then your L is just your slant length, or basically the length which is like sideways. So in this case, pi R plus times R squared plus H squared to the power of 0.5, which is basically using Pythagoras theorem to get that slant length. So afterwards, we will get pi R times R squared. Then we can insert our 4r/3 squared, because the question say that the height of the cone is always equal to 4/3 of the radius of the cone. So afterwards we get that, we can simplify the expression to get 5/3 pi r squared. Then likewise the volume, it will be 1/3 pi r squared h, or we can replace the h with 4r/3. So then we look onto the right hand side of the slide now. So volume is equal to 1/3 pi r squared times 4r/3. We can simplify that to be equal to 4/9 pi r cubed. So now we want to find dV/dr. So we will get pi 4/9 pi 3r squared equal 4/3 pi r squared. Then you find dA/dV. So how I want to find dA/dV, which is the answer we are looking for, is that we split up the dA/dV. So dA/dV is equal to dA/dr times dr/dV, which is basically chain rule. Then we will plunk the things inside, and then we'll get 5/3 pi 2 times 2r times dr/dV. Then, okay, for dr/dV, it's just the inverse of dV/dr. So after you do that, you can then simplify everything, and then you get 5/2r. So essentially, it's inversely proportional to r, because the r is in the denominator. So therefore, in this case, dA/dV is inversely proportional to r. Then for the second question, a manufacturer makes a double-ended color pencils. The shape is formed by rotating a trapezium, PWR's completely about the x-axis, such that the solid is made of a cylinder and two cones. The volume of the color pencil should be as large as possible. So it is given that PQRS lie on a curve, which is essentially a ellipse. Is it? Yes. Yes, a ellipse. No, not ellipse. Wait, it's a ellipse, yes. It is ellipse. Where A and B are positive constants, the points R and S are minus A0 and A0 respectively, and the line PQ is parallel to the x-axis. So part 1 asks you to verify that P, where the angle is between 0 and pi/2, lies on the curve x squared over a squared plus y squared over b squared equal 1. Then asks you to write down and determine the coordinates of Q. Part 2 will ask you to show that V can be expressed in terms of k sine square theta pi times 2 cos theta plus 1, where k is a constant to be found. Then given that theta equals theta 1, find the value of theta which gives the maximum value of V, and show that this satisfies the equation 3 cos square theta plus cosine theta minus 1 equals 0. So the first part, what we can do is that we will just insert the coordinates into the equation. Then afterwards, you realize that we have the a square cos square theta plus b square sine square theta, and you bring them together, make a common denominator. You can then use the trigo identity to show that actually everything will be equal to 1, both on the left hand side and the right hand side. Then to find the coordinate of Q, we go back to a question. So the line PQ is parallel to the x-axis. So what this means is that essentially they both will have the same y value. It's just that the x value will just be the negative version. So in this case, the coordinate of Q will just be minus a cos x and b sin x. Then for part 2, they want you to show that the volume can be expressed as the expression as such. So how we find the volume is that they already say that they have the trapezium, then they take the cone and put it on both sides. So in this case, V will equal to pi b sine theta times 2a cos theta, which is the volume of the cylinder, then plus 2 volumes of the cone, which in this case is pi over 3 times b sine squared 3 sine theta all squared times a minus a cos theta. How you find all those dimensions for the base, the length, and the height? You just look at your graph and you try and make references. So in this case, the height is just a minus a cos theta. Your length of the cylinder is just 2a cos theta, then your radius is as such. So afterwards you get that, then you try and simplify everything. So when you split up the a minus a cos theta, you can actually put 2 and 2 together. So you have 2 minus 2 over 3 to get your 4 over 3 in your fourth line times a b square pi sine square theta cos theta. Then you will have the other separate term, which is 2 over 3 a b square pi sine square theta. You try and factorize everything, you end up getting your 2 cos theta plus 1. Then it turns out that your k will just be 2 over 3 ab square. This may look a bit ugly, especially with all the terms everywhere, but for these kind of questions, just try and bash through and eventually you'll get an answer as long as your math and your logic works perfectly. Then for part 3, given that theta equals theta 1 is the value of the maximum value of v, show that theta 1 satisfies that equation. So we have a volume there, then we just want to differentiate it. So our 2 over 3 ab squared pi is always a constant. Then inside we will differentiate using our commutative law, and then afterwards we will use the product rule. So first part is sine squared theta, then you differentiate the 2 cos theta plus 1, you get minus 2 sine theta. Then on the other side, you will get 2 sine theta cosine theta, cos we differentiate the sine squared theta, times our 2 cos theta plus 1, which remains the same. We then simplify it further by factoring out the 2 sine theta, and then we can get the minus sine squared theta plus 2 cosine squared theta plus cos theta. So the thing is that we want our final answer to be solely in terms of cosine theta or cosine squared theta. So after we get the sine squared theta, we try and remove it with a 1 minus cosine squared theta, which is of course from the identities, which we can use from our MF26. So afterwards we do that, we can rearrange some things here and there. We get our 3 cos squared theta plus cos theta minus 1. So the thing is, if we want it to be a maximum value, of course our dv over d theta will be equal to 0. So this can create two scenarios. Our sine theta is 0, or our 3 cos squared theta plus cos theta minus 1 is equal to 0. So for sine theta equals 0, it's not applicable, because otherwise the pencil will be like a flat line. So that's why we will put it as not applicable. And afterwards we will just, you already show the thing, let's just find the value. How we will find the value is that we just take the entire expression, or the cosine theta, cos theta, and minus 1, put it into a GC, then you will just see what's the solution. In this case, there will be two values, but as they mentioned in this part, they say that 0 is less than theta, which is less than pi over 2. So that's why we had to reject the negative value. And so finally, we get cosine theta equals 0.434. Inverse both sides, you will get theta equal 1.1216 radians. Then the next part, it will be about a cameraman filming a race at a family carnival. A runner runs along the track at a constant speed of p. X represents the location of the runner who starts running from the starting point S. The cameraman positions himself at C, which is 10 meters from the starting point S. CS is the perpendicular distance to the track in the diagram below. Theta is the angle through which the cameraman has to rotate his camera to film the runner who starts running from S. Find the rate of change of theta in terms of p at the instant when the runner is 10 meters from S. So when we want to find the rate of change of the angle, our variable will be theta. So we look at the answer. We then also have our x and our t. So you try and just lay out all the information you have first. So dx over dt is equal to p. Our dx over dt is essentially the speed. So that's how we express it. Then we also can use trigonometry to figure out some expression for theta. So if we look at a triangle we know that tangent theta is the opposite over adjacent, which in this case is the distance run over the constant 10. So let's differentiate everything with respect to t. Secant square theta times d theta over dt equal 1 over 10 dx over dt. Then afterwards, we can then just substitute our dx over dt with the p. So when s equal 10, tangent theta equal 10 over 10 equal 1. So in this case, our theta is just power 4. Then our d theta over dt, we can substitute our theta inside, our dx over dt inside as well, and we will get p over 20 radians per second. So that's the first part. In the second part, another cameraman who is also positioned at C wishes to film two other runners A and B. Both runners start at the same time and run along the track. The first runner, A, runs at a constant speed of 2q meters per second, while the second runner only runs at a constant speed of q. So the angle through which the cameraman has to rotate his camera to film the runners are alpha and mu, where SEB is alpha and BC is mu. So by finding the expression for tangent alpha plus mu, t seconds after the race has started show that our mu is equal to tangent inverse qt over 5 minus tangent inverse qt over 10. So essentially, if you try and make a little observation, actually what happens is that we are trying to find the tangent of the both angles combined, and then how you find mu is that we just take a subtraction of the larger angle plus the smaller angle. So to do this, they already say by considering tangent alpha plus mu. So actually what you can do is that you can take a look at your MF26. So when you look at FF26, you can find a formula for your tangent inverse. But in this case, we can also just look at the diagram itself. So if you find tangent A plus U, we just find the opposite length and the adjacent, which in this case is just 2qt over 10, simplify to qt over 5. Then, if we look at tangent alpha alone, we cannot look at tangent mu because in that case we don't have a right angle triangle. But still, SBC and SAC are both right angle triangles, which is why we are able to use the tangent formulas. So tangent alpha is qt over 10. So A plus mu equals to tangent inverse of qt over 5. Then, because we already have found our alpha, we can also rearrange such that our mu is equal to tangent inverse qt over 5 minus alpha, which in this case is minusing the tangent inverse of qt over 10. So that's how you get the expression. Then afterwards, hence using differentiation, find the maximum value of mu as the two runners run and show that the value obtained is a maximum. What happens again is that we make reference to the formula in our MF26 of how to differentiate mu with respect to t. So we will have 1 over 1 plus qt over 5 all squared. Then we differentiate the qt over 5 to get our q over 5 at the numerator. Then the same can apply for the second part, q over 10 over 1 plus qt over 10 squared. Then afterwards, we try and make q the subject. So afterwards, when you bring all the q to one side and then you solve for t, you can then find the value, which in this case is 5 times root 2 over q. So when t equal 50 over q, I mean square root 50 over q also, you can then find the value of mu, which in this case is just tangent inverse of square root 2 minus tangent inverse of square root 2 over 2, which is 0.340 radians. Then to show that it's a maximum, again you have to do the second round of differentiation. So again you do the same. You do your differentiation, you get minus 2q power 3t over 125 over 1 plus 2t over 5 squared, the whole thing squared, minus 2q cubed t over 1000 over 1 plus 2t over 10 squared, the whole expression squared. Then when t squared equals 50 over q squared, that is where we can substitute our t inside, and then that should prove that the entire expression is less than 0, because the entire thing you will have the negative at the front. So yeah, that is how you can find that the value obtained is a maximum. Then the next part is the curve is given by the equation y equals x times 1 over x to square root, where x is greater than 0. the variable point P moves along the axis from x equal 10 to x equal 1 at a constant rate of 1 unit per second. Another variable point Q moves along the curve C so that the x-coordinate of both P and Q are the same at any point in time. Find dy dx in terms of x, and then if the area of the triangle OPQ is represented by A, so that the rate of change is 1 over 2 times ln 2 minus 3 over 2. So the first part, you have y equal x to the power of 1 over square root x. To get rid of the power, we again apply a ln to both sides to get our 1 over square root x. We will then differentiate with respect to x, and we will find that that is our expression for dy dx, which is x to the power of 1 over square root x over x to the power of 3 over 2 times 1 over times 1 minus ln x times 1 minus ln x over 2. Then they say that if the area of the triangle OPU is represented by A, it is actually meaning the area half xy. So if you want to differentiate with respect to x, we will just do that. So we have half y times differentiation of x, which is just one constant, plus half x times differentiation of y, which is just dy over dx. Then we will have our value of t. So when we substitute t equals 6, x will then be equal to 4. So y will be equal to 2, and then dy dx will be equal to 1 over 4 times 1 minus ln 2. So in this case, dy over dx equal half times 2 plus half times 4 times 1 over 4 1 minus ln 2 equal 3 over 2 minus half ln 2. Then given that dx over dt is minus 1, we can put it all together. So d over dt equal d over dx times dx over dt. Put it all together, then you will get half ln 2 minus 3 over 2 units. Then for the last question, they give you x equal u to the power half, and then y equal 1 over u squared minus 2u. So the first part is find dy dx in terms of u. Second part is that the tangent at x equal 1 intersects x and y at a and c. Then find the equation of the tangent. Meanwhile, the normal at x equal 1 intersect x and y axis at b and d. Prove that AB equals CD. No, you don't need to find the tangent. Yeah. Then, given that u is increasing at a rate of 0.5 units per second, find the rate of which dy dx is decreasing when u equal 2. So the first part is that you will just differentiate x with respect to u and y with respect to u. Then you will just find dy dx, which is just dy over du times du over dx. So you put it together, you will get 4u to the power of minus 5 over 2 times 1 plus u power cube power 3. Then we are gonna use the point x equal 1, y equal 1 as our fixed point. No, x equal 1, u equal 1. Because when x equal 1, then u equal 1. You can use the information of u equal 1 to find the value of y, which will be minus 1, as well as dy dx. Then you just use the standard equation for a tangent. You get y equal minus ax plus 10. Then you find out what happens when y equals 0. When x equals 0, you can find your a and your c. Then you find the equation of the normal. You just take your minus a, you inverse it, or rather divide by minus 1 to get your new tangent, which will be your new normal value, which will be 1 over 8. Use the same coordinates, you get the equation of your normal. Find the value when y equals 0, x equals 0, or x and y, and then you can find your b and d. Then you just find the length. So since both a and b are on the x-axis, as you can see by the y coordinate is 0, and c, d being on the y-axis as the x value equal to 0, you can just simply find it just by doing simple addition and subtraction. If you get your a, b, get your c, d, you can ensure that they are the same value. Then for the next part, they want to see and show that you can get the rate at which dy dx is decreasing when you equal to. So we let our dy dx bg, or rather we can just differentiate the entire thing again. So you get d square over dx square. You simplify and then you get minus 2u to the power of minus over 2 times u cubed times 5. Then you just insert your u equal 2, put it inside. Then dg over dt, or in other words, your dg over dt is just your dg over du times du over dt equal minus 2 times 2 power minus 7 over 2 times 2 cubed minus 5 times 0.5 equal minus 3 over 8 squared 2. So therefore it's decreasing, and it's decreasing at 3 over 8 squared 2. Remember not to write the negative sign in your last part of the answer. So basically what happened with this question is that we let dy dx be g, find dg over du, where dy dx is already expressed in terms of u. Then we just use the equation du over dt equal du over dg times dg over dt to get the answer. So in conclusion, this is basically what you have to memorize for differentiation. So there are some standard things like differentiating a power x, ln x over 4, some trigonometry. Then got some definition as well, which are not exactly the most important, but just good to know. Then another part which I didn't cover is that some questions will ask you to describe the locus. Basically what the locus means, it just means a set of points. So usually the locuses can either be like an ellipse, a hyperbola, parabola, or a circle. Then you just need to say the major vertical axis of whatever length, minor axis of whatever length, or you can write the vertices, which is basically like the extreme right or the extreme left or the extreme top or the extreme bottom points, or like with a center. Basically puts all the information you know about whatever curve you have into your answer. Then for the nth term in a Maclaurin's, for the nth term, it's just n plus 1 times x of our n. Then as a guideline for implicit differentiation, if you have fractions, you can cross multiply to put everything into one numerator. On the case of square roots and cube roots, you can take square or cube on both sides to get rid of the roots. On the case of composite functions, and what composite function means, like let's say you have sine, then inside is like cosine inverse x equal y. You can take a sine inverse on both sides, so you eliminate the sine on one side. So it's just a cosine y equal a cosine x equal a sine y. So that makes things easier as well. Yeah, so that's what I have for differentiation. Some final words is that sometimes some differentiations can be really ugly, but sometimes you just have to batch through no matter how ugly. Because as long as you write it properly and you're using the right logic and everything just flows correctly, you should be able to get the answer. Then even if you don't know what to do for these kind of questions, just try and differentiate anything anyway and just see if you can get 1 or 2 marks here or there. Most of the questions are rather repetitive. It's about finding the maximal, the minimal, or like trying to find a rate of change of certain things. Then just memorize the differentiations. That will save you a lot of marks, especially if it does come out. So yeah, that's all I have. Hope you enjoyed the video and to see you in the next one.